I welcome my channel. Now start the mathematics under the students 12th class. Subject is matrix and determinant. First we start matrix. What is matrix? Matrix is an arrangement of numbers. Matrix is the arrangement of data within a bracket. Suppose there are two schools, school A and B, and number of students of school A in 8th class, 10th class, 8th class, 9th class, 10th class, 11th class and 12th class are as follows: 20, 30, 40, 50, 17. And school B, number of students are 15, 25, 35, 22, 23. If you arranged these numbers within a bracket, that is 20, 30, 40, 50, 17, 15, 25, 35, 22, 23, it is called a matrix. So matrix is nothing else but it is an arrangement of numbers. Here we see that you have two rows, row 1, row 2, column 1, column 2, column 3, column 4, column 5. So arrange the numbers within rows and columns. Hence, now you can define a matrix. So matrix is an arrangement of numbers in a rectangular arrangement. That means matrix is a rectangular array of numbers. Suppose there are mn numbers, A11, A12, A13, A1n, A21, A22, A23, A2n. Similarly, AM1, AM2, AM3, AMN. Now, I replace mn elements, and this arrangement is called matrix, and it is denoted as Aij, n into n. I stands for row and J stands for column. Suppose I write A11. A11 means A is the element present in first row and first column. A12, this means it is an element present in first row and second column. Suppose I write an example matrix 1, 2, 3, 4, 5, 6. Here we arrange 6 elements in 2 rows and 3 columns. This is an element present in first row and first column. So A11 is equal to 1, A12 is equal to 2, A13 is equal to 3, A21 is equal to 4, A22 is equal to 5, A23 is equal to 6. So A11 means it is an element present in first row and first column. A23, this implies that it is an element present in second row and third column. So matrix is an arrangement of numbers. So it is a rectangular arrangement of numbers within row and columns. Now, next we state the order or dimension of a matrix. Order or dimension of a matrix. The order of a matrix is defined as m by n, and it is written as Aij m cross n. As for example, a matrix, you write a matrix 2, 3, 4, 5, 6, 7. The order of the matrix is 2 by 3. So order of the matrix, order is equal to 2 by 3. We write 2 cross 3, but we read as 2 by 3. This means it have 2 rows and 3 columns. A 2 by 3 matrix contains 6 elements. Now I write 1, 2, 3, 4, 5, 6. Here this matrix, it has 3 rows and 2 columns. 3 rows and 2 columns. So order of the matrix is 3 into 2. So order of a matrix is nothing else but it is the number of rows and columns. And order of a matrix shows how many entries present in a matrix. Suppose a matrix order 3 into 5. Hence it contains 15 elements. Number of elements is 15. A matrix Aij, order of the matrix is 2 into 6. So number of elements present in matrix is 12. So from the order we can find the how many entries, how many elements present in the matrix. Now next study about the types of matrix. Types of matrix. Types of matrix. There are different types of matrix. First, that row matrix. Row matrix. If matrix contains only one row, it is called row matrix. As for example, 1, 2, 3, it contains one row and 3 columns. So it is a row matrix. 1, 2, 3, 4, 5. It is a one row and 5 columns. So it is a row matrix. 1, 2. So it is one row and 2 column. It is a row matrix. Only one. It is also a row matrix. So matrix is called row matrix. It has only one row and number of columns may be 1, maybe 2, maybe 3, or maybe any number. So order of the row matrix is 1 into n. So every 1 into n matrix are called row matrix. It possesses only one row and number of columns is n. Next, we start column matrix. Column matrix. A matrix is called column matrix if it contains only one column. Now 1, 2, 3, it is a column matrix. It has 3 rows, 1 column. 1, 2, it is a column matrix. 2 rows, 1 column. 1, it is a column matrix. 1 row and 1 column. So here we have there number of columns is 1, but number of rows may be 1, maybe 2, maybe 3, maybe 4, maybe 5. Hence, the order of the column matrix is n into 1. N into 1. So in a column matrix, we have only one any number. Next, we start the square matrix. Square matrix. A matrix is called square matrix if number of columns is equal to number of rows. Now, I will give an example. 2, 3, 4, 5. Here it contains 2 rows and 2 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 3 rows and 3 columns. 4, 1 rows and 1 column. All are example of square matrix. So a matrix A is equal to Aij m cross n m by n. That means number of rows is equal to number of columns. We call this square matrix. So a square matrix, in a square matrix, number of rows always equal to number of columns. So the square matrix number of rows is equal to number of columns. Whatever may be the elements, they are all real numbers. They are positive or negative, rationals or irrationals, all are real numbers. But number of rows is equal to number of columns. In a square matrix, we have number of rows is equal to number of columns. Next, zero matrix or null matrix. Zero matrix or null matrix. Null matrix. A matrix is called zero matrix if all the elements of the matrix are zero. It may be a row matrix, or may be a column matrix, or may be a square matrix. Here it is a row matrix, but elements are zero, so it is called zero matrix. It is a column matrix, but elements are zero, so it is called zero matrix. It is a square matrix, but elements are zero, it is a zero matrix or null matrix. All zero matrices are denoted by symbol 0. So null matrix or zero matrix is a matrix where the elements, all the elements are 0. Whatever may be the order, but all elements are 0. We say it is a zero matrix. So we know the row matrix, column matrix, square matrix, zero matrix. Next, the diagonal matrix. Diagonal matrix. A matrix A is equal to Aij m cross n is called a diagonal matrix. Is called a diagonal matrix. Is called a diagonal matrix. Diagonal matrix. If number 1, number of rows is equal to number of columns. M is equal to number of rows is equal to number of columns. Number 2, except the diagonal elements, all elements are 0. Except the leading diagonal, all elements are 0. All except diagonal element, except diagonal element, all elements are 0. All elements are 0. Now, what is the diagonal element? So, diagonal elements are Aij are called diagonal element in a matrix. Aij are called diagonal elements if I is equal to j. The matrix must be a square matrix. In a square matrix, suppose a matrix is A11, A12, A21, A22. It is a square matrix. And the element is called a diagonal elements if I is equal to j. So A11, A22, it is called diagonal elements. It is a diagonal, right bottom to left top. It is the diagonal. This is the non-diagonal elements. So in a square matrix, the except diagonal elements, if all elements are 0, that called a diagonal matrix. Example 3, 0, 0, 5. So it is called a diagonal matrix. Here it is a square matrix. Number of rows is equal to number of columns. It possesses 2 rows and 2 columns. And all diagonal elements Except diagonal elements, all entries are 0, all elements are 0. These are the diagonal elements. It is present in first row, first column. It is element present in second row, second column. When the elements present, the number of rows and number of columns are equal, then that element are called diagonal elements. So these are the diagonal elements. So the diagonal elements are not 0. Non-diagonal elements are 0. So it is called a diagonal matrix. A matrix is called diagonal matrix if they accept diagonal elements, all entries are 0. Now it is a square matrix. Give an example of a third order matrix: 3 0 0 0 5 0 0 0 7. So it is also called a diagonal matrix. As it contains 3 rows and 3 columns and except diagonal all entries are 0, so it is called a diagonal matrix. Now the diagonal matrix is converted to a scalar matrix if the diagonal entries are equal. So diagonal matrix is called a scalar matrix. Scalar matrix. Scalar matrix if the diagonal elements are equal. It is a square matrix. Scalar matrix is a square matrix. And number of rows is equal to number of columns. On all diagonal elements are not 0 and are equal. So a diagonal matrix converts to a scalar matrix if elements are equal. As for example, suppose we write an example 2 0 0 2. So it is a square matrix. Number of rows is equal to number of columns. And it is a diagonal matrix, and except diagonal all entries are 0. Now we say it is a scalar matrix as entries are equal. So a diagonal matrix is converted to a scalar matrix if elements are equal. If elements are equal to unity, it is called unit matrix. Unit matrix. As for example 1 0 0 1. So it is a unit matrix. It is a square matrix. Number of rows equal number of columns. It possesses 2 rows and 2 columns. And except diagonal all elements are 0 and diagonal elements are equal to unity. So scalar matrix or diagonal matrix is called a unit matrix, provided elements are equal to unity. If elements are equal to 1, then it is called unit matrix, and it denoted with symbol I2 cross 2. Similarly, I3 cross 3 also example of unit matrix 1 0 0 0 1 0 0 0 1. Now we know what is matrix. Matrix is an arrangement of numbers, mn numbers, but it is a rectangular array of numbers. And the order of matrix is defined as row by column, that is m by n. And types of matrix: row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, and unit matrix. Next, the determinant value of a matrix. We can find the determinant value of matrix. If the matrix is a square matrix, we cannot find the determinant value of any matrix. Determinant value of a matrix is obtained if the matrix is a square matrix. A matrix must be a square matrix. Then we can find the determinant value. Suppose, as for example, a matrix is equal to 2 3 4 5. It possesses 2 rows and 2 columns. Hence we can find the determinant value. So determinant value of the matrix, determinant value of A 2 3 4 5 is equal to 2 into 5 minus 4 into 3. That is equal to 10 minus 12 minus 2. So determinant value of a matrix, second order matrix, can find first element into fourth element minus third element into second element. If a matrix is equal to A11, A12, A21, A22, the determinant value of this matrix is obtained by product of the diagonal elements minus the product of diagonal elements. Product of the diagonal elements A11, A22 minus product of the off-diagonal elements A21, A12. If the determinant value of matrix is not equal to 0, we say that is non-singular matrix. Non-singular matrix. Non-singular matrix. A matrix, square matrix, A square matrix, Aij, M cross N, a square matrix is called singular matrix if determinant A is equal to not equal to 0. If determinant A is not equal to 0, a square matrix determinant A not equal to 0 is called non-singular matrix. Non-singular matrix. Non-singular matrix. Example, a matrix is 2, 3, 4, 5. 2, 3, 4, 5. Now the determinant value of A 2, 3, 4, 5 is equal to 10 minus 12 minus 2 is not equal to 0. So this is an example of a non-singular matrix. If the determinant value is not equal to 0, we say it is non-singular. If determinant is equal to 0, determinant A is equal to 0, we say it is singular matrix. Singular matrix. Example 2, 3, 4, 6. Now the determinant value of the matrix, 2, 3, 4, 6 is equal to 12 minus 12. Product of diagonal elements minus product of diagonal elements, that is 0. Hence this matrix is an example of a singular matrix.